Recently, someone DM'd me asking about help with retrosynthesis of diethyl ether with the stipulation that they had to start from acetylene. This is a nice one, and we were able to do it in just a couple steps with just a little bit of, nudging them in the right direction, because I'm not going to do all the work for you, but I'm going to help you get to where you need to be. So if you're struggling with your retrosynthesis, stay put, because we're going to work through this together. So when you see something like this on your exam, you can get that A. So we need to make diethyl ether, nice symmetric ether. So there's a couple ways you could do this, but my favorite way of making ethers is a Williamson ether synthesis. And what do we need for that? We need an alkoxide ion like this. So we have ethoxide, and I'm going to need an alkyl halide. I'm going to use ethyl bromide. Now, you could make either one and then make the other one the reagent, but for the purposes of this, I'm going to work backwards from, I guess, from ethyl bromide, and say I then reacted it with ethoxide. So how do I make my ethyl bromide? Well, HBr to ethylene. So remember, this is going to add, and it doesn't matter which way it adds, so we don't have to worry about most substituted, least substituted, Markovnikov, anti-Markovnikov, because it's a symmetric molecule. Now, how do we get ethylene from acetylene? Well, we can do a hydrogenation, and I know what you're saying, is well, won't hydrogenation just reduce it all the way down? And yeah, you would be right if we just did H2 palladium on carbon. But if we use a poison catalyst, say like the Lindlar's catalyst, that'll stop us at just the alkene. Ooh, they got a little smudged. Okay, so there we go. We take our acetylene, we hydrogenate with a Lindlar catalyst, we get ethylene or ethene, however you say it, and then we subject it to hydrobromic acid, we get bromoethane. Then we react that with ethoxide, giving us our diethyl ether.